Hiya, it's Mr. Baker here. We're going to be looking at Newton's second law today. Okay, so we're going to be looking at Newton's second law today, and we're going to answer this very important question. We're going to be answering, why is it harder to chuck heavy stuff? Okay, so last lesson I showed you this animation when we were looking at Newton's first law to describe how an unbalanced force causes acceleration, deceleration, or a change in direction on an object. And when we've got a resultant force of 0, then the object remains doing what it's doing, either staying still or going at a constant speed. We can use it again to look at Newton's second law. Now, Newton's second law is all to do with relating the amount of force you've got with how much something speeds up, the acceleration of it, but depending on the mass of the object. So this time I've included the mass of this object. So here you can see I've got a 50-gram box, and I've got my mannequin-y thing, which is going to cause a force on here, and we're going to be able to see how quickly the speed increases. Okay, so let's put a force on there. Okay, so you can see that that's there. If I put a larger mass on there, you can see what happens to the speed. So the increase in speed slows down. So when the mass increases, the acceleration decreases. So it's still accelerating, but it's not accelerating as fast. If I take that fridge off, you can see that the acceleration increases again. Put the fridge back on, and it decreases again. Oh, and he's fallen over again. Okay, let's reset that. Okay, so let me just show you that again. So we have got a little girl who is lifting a man who is lifting a bin, because why not? And we're going to have a look at the speed. So we're going to look at how quickly the speed increases again when this thing pushes them. It's all very random, isn't it? But let's do it anyway. So when we increase the force, let's make it 50 newtons. So you can see that he's pushing with a force of 50 newtons, and that is accelerating this bunch of stuff towards the right. It's accelerating it, cause I know that because the speed is increasing, but it's not accelerating it very much. Let's take the bin away. When I take the bin off, can you see now the mass is less and acceleration is more? The speed is going up faster. If I take the man off as well, it's accelerating faster. So the bigger the mass, the smaller the acceleration. Okay, larger mass again, smaller acceleration, larger mass again, smaller acceleration. Okay, so that's what we said. So Newton's second law relates the mass and the acceleration. So when I've got a constant force, for the greater the mass, the smaller the acceleration. Okay, let's stop there. Okay, so we've just said that when you've got a constant force on something, when you increase the mass, then the acceleration decreases. So basically, when you are trying to push something and you push it, if you're trying to push a heavier thing, it's not going to accelerate as much. If you increase the mass of that thing again, it's going to be harder to push it. You're not going to be able to accelerate it as much. Okay, so let's have a look. So here I've got a fridge, 200 kilogram fridge, and so we've said that the force, if the force is constant, then the acceleration increases when you decrease the mass, and when the mass increases, the acceleration decreases. So let's see what happens if I keep the mass the same this time and I change the force. So let's increase the force. So the mass is going to stay the same. It's going to stay at 200 kilograms. You can see it's speeding up a little bit. Let's increase the force again. What's going to happen to the acceleration? Right, so by increasing the force, you can see that the speed is going up quicker, so the acceleration is increasing. If I increase the force again, the speed is going up quicker again, so the acceleration is going up quicker. Every time I increase the force, the acceleration increases. Okay, so that's that one. I want to show you one more. Okay, so in the last animation we were looking at the speed and how quickly the speed increases. Here we've got an acceleration dial, which might be a little bit easier to see. So I'm going to push on here. So I've got a mass of 50 kilograms. So let's keep the mass constant, and I'm going to increase the force. Let's have a look at what happens to the acceleration. So if I increase the force, so the force is 50 kilograms, but the mass is staying the same, then you can see I've got an acceleration that big. Let's increase the force again. If I increase the force, the acceleration goes up. If I increase the force, the acceleration goes up. Okay, so this time I'm going to, let's make the force 100 newtons, and then we're going to see what happens when I increase the mass. So force 100 newtons, and I get that much acceleration. If I increase the mass, can you see that the acceleration decreases? So when you've got a constant force, when you increase the mass, the acceleration decreases. So this is why when you're trying to throw heavier things, you can't accelerate them as much. And it's all to do with the link between the mass and the acceleration. As the mass of the thing increases, with the same force that you're applying, the acceleration will decrease. Okay, let's stop that there. Okay, so you can relate both of those things that we've just said as graphs. So when we push something with a constant force, if I increase the mass, then the acceleration goes down. And it goes down like this. They're actually inversely proportional. So as this one goes up, this one goes down. If I keep the mass constant and I increase the force, then the acceleration increases. And they're directly proportional. And so as I increase the force, the acceleration will increase by the same amount. When the force is nothing, the acceleration will be nothing. Okay, so that's what we've just seen in those animations, and we can draw graphs of that. And in the next lesson, you'll actually do a practical where you can see this for yourself. Okay, so we've seen how it all works. Let's see what links these together then. So it's actually an equation like this. Force equals mass times acceleration. Force is measured in newtons, mass is measured in kilograms, and the acceleration is measured in meters per second or meters per second squared. So this is our equation that you need to know, and it relates force, mass and acceleration. So you've got to be able to rearrange the equation. So you might want to use something like this, where you have a triangle. Force would go on the top, mass would go down there, acceleration would go down there. If you wanted to find the force, you'd put your finger over there and it would be mass times acceleration. If you wanted to find the mass, then it would be force divided by acceleration. If you wanted to find the acceleration, it would be force divided by mass. Then all you've got to do is you've got to have a way of remembering that force goes to the top. So force first or something like that. And then you know that mass and acceleration go down the bottom. So that's one way you could do. You might just want to rearrange the equation. That might be better in some ways. Okay, so force equals mass times acceleration would be our equation there. Let's have a look at a couple of examples. So how do we use Newton's second law? So a car has a mass of 1,000 kilograms. What force must the car's engine supply to cause an acceleration of 2 meters per second squared? So we have our equation, force equals mass times acceleration. The mass is 1,000. The acceleration is 2. 1,000 times 2, 2,000 newtons. How about this time we've got a lorry of mass 12,000 kilograms. What acceleration is caused by a force of 10,000 newtons? So force equals mass times acceleration is our equation. So we would rearrange our equation and find that acceleration equals force divided by mass, The force is 10,000 newtons, so that goes at the top. The mass is 12,000 kilograms, so that goes underneath. 10,000 divided by 12,000 is 0.83, and its acceleration, so it's 0.83 meters per second squared. Okay, so that's that. So what we've done is we have worked out, or we've looked at why it's harder to chuck heavy stuff, a question that you never knew you wanted to answer. And it's all to do with the fact that force equals mass times acceleration. If the mass is constant and you increase the force, then you'll increase the acceleration. But if you're trying to throw heavier and heavier stuff, so the mass is increasing and you are still throwing with the same force, then the acceleration will be inversely proportional to the increase in the mass. So this is what you should be able to do by the end of the lesson. You should be able to state the factors that will affect the acceleration of an object because of the resultant force. You should be able to calculate the force required to cause a specified acceleration on a given mass, and you should be able to rearrange the equation F equals ma to find force, mass, or acceleration. Okay, so that's been Newton's second law, part of the forces and motion topic. I've been Mr. Baker, and that is that. Thank you very much.